Hi, everyone. Just give a minute for everyone to come in. We'll get started shortly, okay? And Mr. Azasi, if you want to go ahead and start sharing your screen, you're more than welcome to.
Okay, thank you.
Hi, Giselle. I'm glad you're here. Yay, we can see your screen, Mr. Azasi, but I don't hear you.
Okay, can you guys hear me? So I can go get the. Can you guys hear me? Hello.
Yes, we can hear you,
I
Mr.
can hear you
Isai.
now. Thank you, Mr. Azasi.
Okay, let me share my screen so I can go get the PowerPoint.
Yes, sir.
Okay, let me see here. It's gonna be.
We can see it.
Okay. Let's see here. This will be under. Okay, let me start from the beginning. Should I start?
Yes, sir.
Okay. Good morning. Good afternoon, guys. Today we're going to cover sets, which is section 8.1 and a little bit of 8.2. The topics covered today are going to be sets, subsets, proper subsets, operation on sets, intersection of two sets, union of two sets, disjointed sets, and Venn diagrams. Okay, to begin with, sets. A set is a well-defined collection of objects. In this PowerPoint, there's a lot of like vocabulary or ideas that you guys have to know. Okay, that's why I want to take my time with this because there's like I said, there's vocabulary words that you have to understand what they mean. Okay, for example, a set is a well-defined collection of objects. Examples of sets: well-defined collection of objects can be all the students in my math class. Letters in the alphabet. You see, these are well-defined objects. Let me give you an example of something that's not well-defined. For example, the collection of young adults is not well-defined because this is too broad. But if I add between the ages of 18 and 29, then it's well-defined. So for example, the collection of young adults between the ages of 18 to 29, now it's well-defined. Okay, capital letters such as A, B, and C are used to name sets. Each object in a set is called member or element of the set. The set braces are used to enclose objects in a set. Okay. This is an example. This is set A. Right? It's going to be set A consists of elements 3, 4, and 5. You see, so everything that I covered here, guys, with a capital, with just capital, and with the braces, it's all defined here. Capital letters such as A, B, and C are used to name sets. So this is set A. And each object in the set is called a member or an element. All these are called members or elements. I think in this book they like to call them elements. So 3, 4, 5 are the elements, and the braces or the brackets they have all the elements enclosed on that set. Okay, now the symbol. This symbol here means it's an element of the set. And this other symbol, every time there's like a line through it, it means it's a negation. It means not. So this symbol means it's not an element of the set. Okay, example. Okay, we have the same set A, with elements of 3, 4, 5. So this is a true, right? Like a true statement. 3 is an element of set A because 3 is in A. You can write it this way, or you can say 3 is an element of the set 3, 4, 5. It means the same thing. You see, and here's the wording. 3 is an element of set A, or 3 is an element of the set containing 3, 4, and 5. Okay, now, 2 is not an element of A because 2 is not inside the set. Or you can say 2 is not an element of the set containing 3, 4, and 5. And there's how you say it. 2 is not an element of set A, or 2 is not an element of the set containing 3, 4, and 5. This is going to be sets, definitions, and examples. Okay. Empty set. What's an empty set? An empty set is a set with no elements. And here are the symbols for an empty set. It's like a zero, or like a null with the lines through it, or just the braces with nothing inside the set. Okay. These two symbols are used to signify empty set. I believe in this book they only use this symbol here. Okay, but this is also correct. Equal sets. Equal sets, they are sets that contain exactly the same elements, exactly the same. These are equal sets. For example, 3, 4, 5 is equal to 5, 4, 3 is equal to 4, 3, 5, which means the order does not matter as long as every element, the exact same elements are in each set. They're called equal sets. Sometimes we describe a set by a common property of its elements rather than the list of its elements. For example, up to this point, we list the elements. Okay, now there's another way to describe a set. The property can be expressed with a set building notation. Okay, so this is another way to represent sets. It says, this means a set X such that X is a property of P. This is how you read it. The set of all elements X, right? The set, which is the brackets, about elements X, and the line, this line here means such that X has a property of P. Okay, so let me show you what everything, break it down. The set, right, means the brackets or the braces. That means the set. Of all the elements X is the X, is an X right there. This line here means such that. And then you have X as a property of P, right? X is a property of P, which is all that right there. That's a property. Okay, right now I'm going to show you some examples. Examples. List the elements in a given set. Here it says the set X such that X is a natural number more than 5 and less than 8. And for B, it says the set X, the set of elements X such that X is an integer and saying that it's between -3 and 1. Okay, so what's the answer for A then? Okay, we're going to list them now. So the answer here will be the set will be 6 and 7 because natural numbers between 5 and 8 are going to be 6 and 7. So that's my answer for that one. Okay, now the integers, the set of integers between -3 and 1. This is -3, right? The -3 is not included because if -3 is less than X, is less than or equal to 1. The -3 is not included, but the 1 is. So we have -2, -1, 0, and 1 is my set that we're looking for. Okay, now you need to know this. Okay, hey guys, this was from 0301, but now we don't do no more 0301s. I think we do 0305 or 0324 or 0314. But this is something from the 0301 book when they used to have the course 0301. Whole numbers, they start with 0 and they go to infinity. Counting numbers, they start with 1 and they go to infinity. Natural numbers are counting numbers. Okay, so again, whole numbers begin with 0 and go to infinity, and counting numbers begin with 1 and go to infinity. So you need to know that. Now, state whether the statement is true or false. Okay, so on number 1, it's saying 3 is an element of the set 2, 5, 7, 9, 10. Is that true or false? Someone. It's false, right? And here's the reason why. 3 is not an element of the set. How about number 2? Is 2 an element of the set 2, 5, 7, 9, 10? This one is true because 2 is an element of the set. Look at number 3. It's saying 6 is not an element of the set 1, 3, 5, 7, 9. Is that true or false? Very good, guys. Okay, it's true. And why? Because 6 is not an element of the set. How about number 4? 4 is not an element of the set 2, 4, 6, 8. Okay, so it's false, correct? I see on the screen that it's false, and you're right, it's false. 4 is an element of the set because this is a negation. That's why it makes it false. How about number 5? The set 1, 2, 3, 4 is equal to 4, 2, 3, 1. Very good, guys. It's true. Both sets are the same elements. How about number 6? The set ABC is equal to the set ABCD. That's also false. Both sets do not have the same elements. The first set does not contain the element D. If the first set would have the element D there, then it would have been a true statement. Okay, now, all the whole numbers greater than 5 and less than 9 equals to 6, 7, and 8. Is that true? Yes, it is. And this is the reason why greater than 5 and less than 9 means the whole numbers between 5 and 9. Okay, look at number 8. Okay, be real careful with this one. Number 8, the set of all natural numbers not greater than 4. Is that true or false? False. Very good. It's false. Why? 0 is not a natural or counting number. That's why remember that the natural numbers start with 1. Okay? Okay, now look at number 9. It reads, the set of the elements x, such that x is an even integer, and x is between 5 and 19. X is less than or equal to x is less than or equal to, x5 is less than or equal to x, and x is less than or equal to 19. Is this true or false? Equals to 6, 8, 10, 12, 14, 16, the set. This is false. Very good, Giselle. This is false, guys. Why? Because the 18 is missing. Right? 18 is missing on the set, on this set here. Number 10. The set of x such that x is a vowel. All right, all these vowels, is any vowels missing? A, E, I, O, U. Those are all the vowels, right? So it's true. All the vowels are listed. Okay, now we're going to do subsets and proper subsets. Okay, so we have to know what both of those mean. And also a universal set. A universal set is a set that contains all the objects being discussed. For example, whenever we teach this course here, I always tell my students. For example, I can say that my class, you guys are the universal set because nobody else is in my class, only you guys. So that's the set that contains all the objects being discussed, and the objects are my students. Okay, so I would like to share that with my students for universal set. Okay, now what's a subset and proper set? Here's the definition. A lot of students get mixed up with these. I recall when I was taking this course, it was a little bit challenging at first. Okay, but I try to make it as simple as possible. So it says here, a set A is a subset of set B. When you have a subset, this is how you write it, okay? This is the notation. A is a subset of B. But this must take place, provided that every element of A is also an element of B. So in other words, everything that's in A must also be in B for A to be a subset of B. Okay, now, set A is a proper subset of B, of the set B. This is how you write it, written as A is a proper subset of B. And here's a condition. If every element of A is an element of B, but B contains at least one element that is not in A, that is not a member of A. Okay, we're now showing examples, and I'll show you where how this rule applies here. Now, when A contains an element that is not in B, then A is not a subset of B, and we write it as A, right? So we negate the subset of B. That's what it means, negation, which means it's not a subset. Okay, now, also this is something that you gotta know too. For any set A, the empty set is always a proper subset of A, and the empty set is a subset of A, and every set is a subset of itself. Okay, this is crucial to understand this, okay? Okay, now, examples. It's A equals to the elements A, B, and C, and set B is equal to the elements A, B, C, D, and set C equals to the set of the elements of C, A, B. Okay? So now, okay, let me go back here, guys. So these are the rules here, okay, guys, for A. A is a subset of B. Check this out. Let me see, right? Look at the definition here. A is a subset of B, provided that every element of A is also in B. So is every element here, A, B, and C, also in B? Yes, that's why every element in A is also in B. Okay, now, A is also a proper subset of B. It's true, because every element of A is also an element of B. But B contains at least one element not in A, which is the element D. Again, guys, you see, everything in A is also in B, but B has something that's not in set A. That's why it's called a proper subset. If you reverse them, like B is not a proper subset of A, right? It's true because everything in B is not in A. Okay, that's why every element in B is not in A. Now D, A is a subset of C. Every element in A is also in C. Okay? And now E, A is not a subset, it's not a proper subset of C. And why? Because if you notice, set A and set C are equal. And the rule is, right, for a proper subset, that every element in set A has to be also in set C. But C has to have an additional element that's not in A. That's why, here's the reason behind it. A is not a proper subset of C because A is equal to C. And for it to be a proper subset, right, we go back here at the definition. A set A is a proper subset of set B if every element in A is also an element in B. But B contains at least one element that is not a member of A. That's what takes place here. Okay, now, the empty set is a proper subset of A. The empty set is a subset and proper subset of any set. You see, going back to the definition here. Okay, now, let's put it to the test. Okay, here, guys, this is, oh, I should have put that in red too. I forgot to put that in red. This is from the homework, guys, something like the homework. Okay, they give you let A equal to the set -4, 0, and 4. Set B equals to -3, -2, -1, 0, 1, 2, and 3. And set C is equal to -4, -1, 0, and 4. And set D is equal to the just 0, to the element 0. And set and U. Set U is equal to -4, -3, -2, -1, 0, 1, 2, 3, and 4. This is a universal set, right? The universal set is always denoted by capital U. That means universal set. Here it's saying insert proper subset, right? This is a proper subset, or not a subset to make the given statement true. So these are the only two choices that you have. Just these two here, okay? So these, I got it more or less from the homework, but I just changed it a little bit, so it won't be exactly the same thing because I'll be giving you the answers, guys, okay? But it's something similar to the homework for this section here. Okay, number 11. We have A, right? We have A. and we have U. So is A a proper subset of U? What do you guys think? This is subset, this is proper subset, this is not a subset. So yes, it is, right? So here, hey guys, let's call this 1 and let's call this 2. And you guys tell me by 1 or 2 what goes here. So here, guys, right, it's going to be 1. And the reason behind it, every element of A is an element of U, but U contains at least one element that's not in A. And here, guys, it was a whole bunch, right? Because only -4, 0, and 4 are from A. So the rest, you see, they contain at least, you contain at least one element that is not in A, which is -3, -2, -1, 1, 2, and 3. Okay. How about number 12? Okay, let's look at E. E is -4. And A is -4, 0, 0, 4. So what goes here? Is it 1 or 2? This is 1, this is 2, right? So 1 is proper subset, and 2 is not a subset. So the 1 goes there. And why again? Every element of E is an element of A, but it contains at least one element not in E. Okay, I'm sorry about that. I'm going to jump the gun. So for 13, if we reverse it, we put A in E. Let me go back one. Right, we put A in E. So every element in A, is it in E? No, right? So it's got to be number 2 here, which is not a subset. Okay, and again, there's the reason behind it. Every element of A is not in E. Elements 0, 4 are not in E. Okay. How about the set B and C? So what should go here? We have set B, we have set C. Right, so it's like number 2, right? So it's going to be this one here, not a subset. And here's the reason behind it. Again, every element of B is not in C. Elements -3, -2, 1, 2, and 3 are not in C. How about 15? Is it 1 or 2? Is it a proper subset or not a set? Right? Going back to the rule. Every empty set is a subset or proper subset of any set. Number 16. We have the set 0, 1 is blank of set D. So it's going to be what, number 1 or 2? Very good, number 2, right? Is not a set. And the reason behind it, every element of set 0, 1 is not in D. Element 1 is not in D. How about if you reverse it? D is blank of the set 0, 1. Very good, guys. Yes, 1, right? So it's a subset. I mean, it's a proper subset. How about number 18? We have D. D is 0, and B is -3, -2, -1, 0, 1, 2, and 3. So what should go there? Very good, right? It's going to be, well, oh, I forgot the reason behind it. But D, right? So this one here is going to be a proper subset. And here's the reason behind it. Every element in D is also an element of B, but B contains at least one element not in D. Okay. How about number 19? We have A, the set -4, 0, 4, and we have C. -4, -1, 0, and 4. So it is going to be number 1, which is the proper subset. Every element of A is an element of C, but C contains at least one element not in A. Hey guys, for these exercises, I wanted to add the set, because here they only give you 2 choices. So in my opinion, they should have put also the set, if it's a set, so that way you would have had 3 choices to choose from. But I kind of followed the homework, so when you guys do the homework, you can use these examples here. Okay, okay, now list all the possible subsets for each of the given sets. Okay, remember a subset. Okay, so for A, recall, a set A is a subset of set B, written A is a subset of B, provided that every element in A is also in B. So for A part, right, so here's my solution. Remember that you always start with the empty set, right? So the empty set is a subset of the set 4, 6. 4, the set 4 is a subset of the set 4, 6. And also the set 6 is also a subset of the set 4, 6. And every set is a subset of itself. So here we have 4, right? So so here is going to be the empty set, the set 4, the set 6, and the set 4, 6. If you notice, a set with 2 elements has 4 subsets. That's crucial because this is leading to a formula that's coming up. Remember, if you have 2 elements, you can have 4 subsets. Now let's try B. So B, right, we start with the empty set. The empty set is a subset of the set A, B, and C. Set A is also a subset of the set A, B, and C. And set B is a subset of the set A, B, and C, and also set C. Okay, I do them here like in pairs, guys, because it's always good to have some kind of order. I start with the empty set, then I'll start with 1, right? And then I'm going to start with 2 of them. So the set AB is a subset of the set A, B, and C. Now I'm going to go, the set AC is also a subset of the set A, B, and C. And then I'm going to use BC. The set BC is a subset of the set A, B, and C. And lastly, a set is always a subset of itself. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So a set with 3 elements has 8 subsets. Okay, now here's my a definition here. The set of n distinct elements, right? This set of n distinct elements has 2 to the n subsets. You see if it's true, right? So this was 2, right? 2 elements. So 2 squared is 4. It's correct. This was 3 elements, so 2 to the 3rd power is 8. That's how you do them. Okay, now this is also from the homework. Find the number of subsets of the given sets. Can anybody tell me number 20? How many subsets are they going to be? You can put it in the chat if you want to. Okay, what's the rule? Yeah, so it's 2, because it's going to be 2 to the power of the elements. There's 1 element, so it'll be 2 to the 1st power equals to 2 subsets. 2 to the 1st power is 2. How about number 21? How many elements do we have? 3. So it's going to be, very good, Rafael. So it's going to be 3 elements, so 2 to the 3rd power equals 8 subsets. How about this one here? Okay, remember, x is a whole number less than 5. Remember, the whole number starts with 0, correct? So it's 0, 1, 2, 3, 4 is what the set of the set of x, elements x, such that x is a whole number less than 5. So it cannot be 5, it has to be less than 5. So you start with 0. So 0, 1, 2, 3, 4, and 4. There's 5 elements. So 2 to the 5th power equals to 32. Hey guys, I'm trying to give you guys the explanation as I go along, and we're actually doing some of the homework problems from that section. Okay. Okay, now this is given a set A and a universal set U. The set of elements of U do not belong to A is called the complement. The complement of A is written. This means read it as A prime, or I like to say not A. Okay, it all means the same thing. Okay, now, so this is my universal set. Remember, this is the sets being considered, and that's or discussed. That's it. No other numbers, no other elements can go in here. This is the set being discussed. So let the universal set U equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the set A equals to 1, 2, 3, 4. Okay, so here we go. So I'm also going to draw, guys, like a Venn diagram at the same time, because you're going to have to be drawing Venn diagrams. And on 6.2 is where you actually get a heavy dose of Venn diagrams. So I want to prepare you as we go along. Okay, so this is my universal set, right? So this is like the set being considered. You see it's enclosed, right? So that's U. And this is set A. So then the complement of A, which means not A, is going to be the outside. This is not A. Okay, now let's actually put all the elements. So find not A or A prime or the complement of A. A means the same thing. So, right? So set A is equal to, right? So this is not A. 5. Oh, it's right here, guys. My bad. Let me go back. Previous. 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 Okay, check this out, guys. So this is the way I like to explain it to the students. So A complement means not A. So you go back to the universal set here. Not A means not 1, not 2, because right, A is 1, 2, 3, 4. So it's going to be not 1, not 2, not 3, and not 4. You see, I scratch them out. So what's left? 5, 6, 7, 8, 9, 10, 11, 12. So that's the complement of A or not A. Now, let's actually do a Venn diagram and actually show what's taking place here with the Venn diagram. Okay, there's my universal set, right? And there's my set A. So what's set A? Isn't it 1, 2, right? I'm getting from here. 3 and 4. That's set A. So not A means it's 5. It's not inside of A. So I'm going to put all these on the outside because this means not A. So if this is A, set A, not A will be everything else on the outside. But it's still inside the universal set. So 5, 6, 7, 8, 9, 10, 11, and 12. That's how you express. That's how you express this in a Venn diagram. Okay. Now, given two sets, A and B. The set of elements belonging to both A and B is called the intersection. Because I put this and because intersection means and. It stands for and. Because it's A and B, they both have to be there to be true. It's called the intersection of two sets, and this is how you write it. This is the notation, written as A intersects B. This means elements belonging to both sets. But at times, that's gonna, for some reason, at times students still don't get it. So that's why I came up with this phrase here. What do they have in common? And when I say that, it kind of clicks because what they have in common is the intersection of both sets. Okay, going back to the set universal set that I used earlier. But now I'm going to also add B, right? So this is set A, 1, 2, 3, 4, and set B was 2, 4, 6, 8. So find A intersects B or A and B. Okay. So first, guys, what do they have in common, right? Or elements that belong to both, right? So what do they have in common? They have in common a 2. Because 1, they don't have in common. 2, they have in common. How about 3? No. And 4, they have in common. So that's my set of A intersects B. Okay, now how do we represent that in a Venn diagram? Okay. So again, this is my set U, right? So this is set A and set B. That's set A and set B. So the intersection is this part here. What they have in common is this part here. That's A intersects B. Okay. Now let me do it again and actually set it up so it can be more visual. So this is my universal set. This is set A, right? You always start where they intersect, right? This is set A and set B. So where they intersect, right, what they have in common is the 2 and the 4, so you always start there. Then, right, that's what they have in common, so then this is set A, so what's missing? 1. Right, so set A is going to be 1. There's my 2. I need 3. And there's my 4. You see, so this is set A. 1, 2, 3, 4. And here is what set A and B have in common. Okay, now let's do B then. So set B is this set B. So set B is 2, 4, 6, 8, right? So 2 is already there. and 4 is already there. So then we have to put the 6 and the 8 going the outside. Okay, now guys, when you're doing like problems, right? Like application problems, you always start where the two sets intersect, when there's two sets. And when there's 3 sets, you're going to start where all 3 intersect. Okay, which I'm going to show you an example later on. Okay, so what goes here, guys? What's out here are the elements that are not inside these two here. So we have 1, 2, 3, 4, right? So 5 is missing, so 5 goes in the outside. We got 6, 7 goes in the outside. We got 8, 9 goes in the outside, 10 goes in the outside, 11 and 12. That's how you construct a Venn diagram with the given information. Now, these are called disjointed sets. Disjointed sets, it says here, here's the definition, for any sets A and C. If A and C are disjointed, then A intersect C is an empty set. That means they don't intersect. Disjointed means that they don't intersect. Okay, it's going to be the empty set. How do we express it? Again, with the same universal set as before. We got the same A, we got the same B, but now we added C. C is 5, 7, 9. Okay. So 5A intersects C. What do sets A and C have in common? If we notice, right, set A has a 1. Does it have a 1 over here? No. How about a 2? No. How about a 3? No. A 4? No, it's not there. So they don't have nothing in common. Nothing, right? So how do we express it? It's the empty set, right? The symbol, or you can put the brackets also. Okay, now how do you express it in a Venn diagram? There's my universal set, there's my set A, and there's my set C, right? They don't intersect. That's what that means. Now, let's do it again and actually put the elements there. So this is my universal set. So set A consists of 1, 2, 3, and 4, right? This is my set A. And set C consists of 5, 7, 9, and 11. Now, what goes in the outside, right? So because every element has to be taken into consideration. So we have 1, 2, 3, 4, 5. What's missing? 6, right? So 6 is in the outside. We got 7. What's missing? The 8 in the outside. We got 9. 10 is missing, so we put in the outside. 11 and 12 is in the outside. That's how you express a Venn diagram with the given information. Okay, now comes the union. Union means union of two sets, or the word or, because it's one or the other. Okay, given two sets, A and B, the set of elements belonging to set A or B is called the union of the two sets, written as A union B. Okay, this is my saying, so students can actually understand it, because at times when I explain the way it is with the definition, at times students still don't get it. So I came up with ways for them to understand it. Okay, and here's the phrase that I came up with: list all elements of both sets, but do not repeat. In other words, if the element is already there, don't put it again. Okay, and here's how you do that. Here's we're going to execute this phrase here. Again, we have the same universal set from 1 to 12. That's set A and set B, right? So here's how you start it. Find A union B. First, you start with set A. What does set A have? 1, 2, 3, 4. That's how you start with. With the first set that's written down. Now you go to B, right? So it's 2. Is 2 already there? Yes, so we don't put it down. How about the 4? Is 4 there already? Yes, we don't write it down again. How about the 6? No, right? So we put 6. How about the 8? No, it's not there, so we put the 8. So that's your answer, guys. Okay. Now, how do we express that in a Venn diagram? Right, again, this is the universal set U. So now, that's A, this B, and A union B is all this together. Everything, all this together, that's A union B. Nothing in the outside, just what's here and here. That's what A union B is, okay? Okay, now, I tried to put some color there, guys, but to me it was kind of hard because some of the apps wouldn't let me. So that's why I was struggling because I wanted, for it to be shaded. This right here where they intersected, but for the A union B, everything would have been shaded, okay? But on the next slide, I believe, or the next, the slide to this one, it has what I just covered with everything shaded. So again, this is a universal set. Right, so first, we're going to put everything on set A. We have 1, right? Because remember that here's where they intersected. We got 2, we got 3, and we got 4. Because that's where they both intersect, the 2 and the 4. Now, if the 2, right, 2 is already there, right, so we're going to put it again. How about the 4? The 4 is already there. Now, so we can put 6. Let's say B, we're going to put 6, and we're going to put 8. So now, we have 1, 2, 3, 4, right? So we need to go all the way to 12. So the 5 is not in here, so we're going to put it on the outside. Anywhere but in the outside of A union B. The 6 is there, so what's next? The 7. We got the 8, now we need the 9. Now we need 10, 11, and 12. They are going the outside. That's how you express it in a Venn diagram. Okay, now operations on sets. Here's where what I just explained, guys, okay? And it's very crucial for you guys to understand this. And here I do have, the shading. So not A means not A is equal to the set with the element such that X is not in A and X is an element of U. That's how you express it. So not A, right? So this is A. So not A means everything else on the outside of A. The intersection of A and B is A intersects B is a set of elements X such that X is an element of A and X is an element of B, right? That's the intersection, which is this part here. Now the union, A union B equals to the set of elements of X such that X is in A or X is in B or both. That's how you express it, okay? Okay, now these exercises, guys, are also similar to the homework. They're going to give you the U equal to A, B, C, D, E, 1, 2, 3, 4, 5. And set X equals to A, B, 1, 2, 3. Set Y equals to B, D, 1, 3, 5. And set Z equals to B, 2, 3. List the members of each of the given sets using set braces. So in other words, they want you to put it like in brackets, okay? So X intersects Y. Okay, so there's my X. I'm gonna write, because it's all this, guys. I'm gonna put X, then I'm gonna put not X, right? Because we're gonna use not X. I'm gonna put Y and not Y. So for example, going back what we learned earlier, if X is equal to A, B, 1, 2, and 3, right? And this is my universal set. So A means, right? So A, so not A, not B. So I gotta put C, D, and E, right? That's part of the complement of X. And also we have 1, 2, 3, and X. So not D, so it's gonna be 4 and 5. So this is the complement of X or not X. It's a set of C, D, E, 4, 5. Same thing with Y. Y equals to the set B, D, 1, 3, 5. So we go to the universal set, right? So we have A, right? So A is not here, so this is not B and not D. So I'm going to have A, C, E from the rest of the alphabet, A, C, E. And here the numbers 1 through 5, right? 1, 2, 3, 4, 5. So not 1, not 3, not 5. So it's going to be 2 and 4. That's why this is the set of the complement of not Y or Y prime. And there's my Z. So now, let's do number 23. X intersects Y, right? Which means, what do they have in common? Do they have a in common? No. How about a B? Yes. How about a 1? Yes. How about a 2? No. How about a 3? Yes. Anything else? No. So that's the intersection of X and Y. Okay, now union. X union Y equals, remember guys what I said, with union, you're going to write everything that's on the first set first. So you're going to write everything in X, which is A, B, 1, 2, 3. Now we go to Y, to the Y set. Is B already there? Yes. We don't put it again. Is D there? I mean, is D an element of set X? No, so we're going to put D. How about the 1? 1's already in set X, so we don't put it again. How about 3? It's already there. How about 5? No, so we're going to put the 5, and that's it. So that's that's my set of X union Y. How about not X? You see, that's why guys, I'm like to put it on the side because it'll be easier to do other work. So this is like a strategy that I came up with. If you're looking for not X and not Y and stuff like that, so you do them here. That way you can just look at it here. For example, this is the answer. Oh, okay, guys, going back to 24. The book, and back in the book, the answers will always be in order, but it doesn't matter because these are the same. On your My Math Lab, if you put this as the answer, it's going to kind of right, because remember, these are equal sets. As long as they have the same elements, it's correct. The order does not matter. But in back of the book or My Math Lab, the solution will always go in order from A to Z, and also from the smallest number to the largest number. Okay. Now for not X, right? So this is the answer for not X. I already did it here. So that goes there. Now I have the intersection of X. Not X intersects not Y, or the complement of X intersects the complement of Y, right? So we go back over here. So then they equal. Do they both have a C? No. Oh, yes, they do. They have a C, right? So C goes in there. How about a D? No. How about an E? Yes. How about a 4? Yes. How about a 5? No. So that's all they have in common. So that's the answer for the complement of X intersects the complement of Y. Okay, now here we have the complement of X, which is this part over here, right? That's complement of X or not X, and intersects Z. So then, right? So let's start here. Do they both have a C? No. Do they both have a D? No. How about an E? No. How about a 4? No. How about a 5? No. So what's the answer? Empty set. Or that symbol with like a 0 or an O with a slash on it. Okay, now number 28. You have X union parentheses Y intersects Z. So here, guys, you also have to follow PEMDAS, so you have to do what's in parentheses first. Okay? So it's going to be X union, right? So let's find Y intersects Z. Let's do it over here. So that means what does Y and Z have in common, or what elements are in both sets? So let's go to Y, right? Y and Z. Do they both have a B? Yes. Do they both have a D? No. A 1? They don't. A 3? Yes, they do. So that's Y intersects Z. Okay. Now we're gonna put X, right? So now we're gonna put X again, right? Because it's X union B3. So again we're gonna put the X, right? Because it's first. A, B, 1, 2, 3. Now we go to the set B3. Is B already there? Yes. So we don't write it again. Is the 3 already there? Yes. So we don't write it again. So this is my answer. What's there? Okay. Now, from the Venn diagram, list the universal set U, set A, set B, set C, the set of A intersects B, the set of A intersects C, and the set of B intersects C, and the set of A intersects B intersects C. Okay, so here we go. So this is right, set U is a universal set. Set U is equal to, right, so it's going to be everything that's here. So it's going to be A, B, C, D, E, F, G. That's my set U. Okay, now, set A. Set A is going to be A, D, E, G. Now, set B. Set B is going to be B, D, I'm trying to go in alphabetical order. B, D, F, G. B, D, F, G. There it is. How about set C? set C is going to be a C, E, F, G. C, E, F, G. Okay, now let's find A intersects B. What does A, right, set A and set B have in common, right? So it's this part here. So A intersects B is going to be DG. Now let's find A intersects C, right? So A intersects C will be this part here, right? That's where they intersect. So A intersects C is equal to EG. Okay. Then finally, no, not yet. So B intersects C. So B intersects C will be this part here, which is going to be FG. Now, where do they all intersect? Where does A intersect B intersect C? Is going to be this part here, right in the middle. Hey guys, and that's crucial to understand because when you're going to be solving like a Venn diagram, when you always start here, guys, and you work yourself out. So you start here, and then maybe here and here, and here, and then you go to the set A, B, and C. I'll show you an example how to work something like that, guys. But you always work here where the all three intersect, which is just G. Okay. Now, I believe this is the last slide here. Okay. So this is number 30. I did 30 examples or 30 problems here. Okay. So it says 60 people were contracted and responded to a movie survey. The following information was obtained. 6 people like comedies, dramas, and science fiction. Why did I put it in red? Because that's where they all three intersect. Okay. Then 13 people like comedies and dramas. 10 people like comedies and science fiction. 11 people like dramas and science fiction. 26 people like comedies. 21 people like dramas. 25 people like science fiction. Now you have to answer these 4 questions here, A, B, C, and D. So A, it says use a Venn diagram to illustrate the survey's results. So you have to put all these right here, guys, into a Venn diagram. Then from there, once you have the Venn diagram, because it's easier because it's more visual when you draw a Venn diagram. Then for B part, how many people surveyed like comedies, but neither dramas nor science fiction? And then see how many people surveyed like dramas and science fiction, but not comedies. And then finally for D, how many people like none of the movies? Okay, so here's how you start. You start right with the universal set. What's the universal set? Is going to be 60, right? Because 60 is the people being considered. Okay, so there's my 3 sets, so you have U equals 60. So then you're going to call this, so first guys, let's begin, say for example, since comedies start with C, I'm going to let C equal, the set C equals to comedies, right? And then I'm going to let the set D, right? Okay, so that's my set C right here. Then I'm going to let my set D equal to drama, so I believe I'm going to let that one be dramas here. Then for science fiction, I'm going to let S equal to science fiction, and that'll be this one over here. Okay. Now, remember, you always start here where they all intersect. Okay, so again, you start at the intersection of all 3 sets. So you can start at C intersects D intersects S, which is 6, right? I got it from here. That means that this is equal to 6 right here. That's 6, right? Where they all intersect. Okay. Now, then we go in order. 13 people like comedies and dramas. So comedies and dramas, right? So it's going to be this part here. Comedies and dramas is 13, right? So if this is only 13, that means this is not 13, guys. All this has to be 13, so that's already 6, right? So this has to be 7. Why? Because 7 plus 6 is 13. That's why you always start where they all 3 intersect and you work yourself down. Well, now what's next is the next one at hand. The 10 people like comedies and science fiction. So comedies and science fiction will be this part here, right? So this will be this part here. So if it's 10, we already have 6, so that has to be 4. Okay. Now, what's next? People like dramas and science fiction. So dramas and science fiction is this part here, right? Because S and D is right here where they intersect. So it's 11, right? So if it's 11, and that's 6, that has to be 5. And then you go to the single sets. So now let's go to C equals 26, right? So all this must be 26. A mistake that students make is they put 26 here and it's going to be wrong because this whole set C is 26. So you're going to add 4 plus 6 plus 7, right, which is 17, and you subtract it from 26, which the answer will be 9, because all this must equal to 26. Okay. Now, 21 people like dramas. Dramas, all this must be 21. So we have 5 and 7 is 11, plus 7 is 18. 18 minus 21 will be 3. And how you can keep checking your work, guys, is that all the set in D, which is dramas, must be equal to 21. And now 25 people like science fiction. So all this here, guys, this the set is must be 25. Okay, so we have 4 and 6 is 10. 10 plus 5 is 15. So 25 minus 15, so then 10 has to be here. And there it is. Okay. Now you have to find what's in the outside. So how do we do that? We're going to add 9 plus 7 plus 6 plus 4 plus 10 plus 5 plus 3, right? Equals to 44. So then to find out how many people, here on the outside, there was 60 total, right? So it's going to be 60 minus 44, so it's 16. So 16 are out here. They're not into the movies. Okay? So now let's answer the questions A, B, C, and D. So for A part, guys, this is your answer for A. Use a Venn diagram to illustrate the service results. So I just did that. Now, for B, how many people surveyed like comedies, but neither dramas nor science fiction? Right? So you're going to go to comedies, right? Comedies is all this right here. But it's saying that they didn't like dramas nor science fiction, so you take these out. So how many people only like comedies is going to be 9. See, there's my 9. Now, how many people surveyed like dramas and science fiction, but not comedies? So let's go to dramas and science fiction, right? So dramas and science fiction will be these two here, right? So they're talking about these two here, but not comedies. So not comedies means not these, right? So what's my answer? Will be 10 plus 5 plus 3, which is 18. The answer is 18 for that one. Now for part D, how many people like none of the movie styles? So how many people were not were here like none of the movies, which would be the outside, which is 16. That's how you do the Venn diagrams, guys. This was a little bit more challenging than the rest. This is something from 8.2, and I believe, guys, that's my PowerPoint and my presentation. You guys have any questions? Okay, guys, let me stop sharing them. So let me go here. Let me go here. Hey guys, did that make sense? Okay, now guys, if you guys want a copy of this PowerPoint, send me a text. Okay, I'm gonna put, because this will be like actually in video under the recordings. But at times it's good to just practice with a PowerPoint and just practice at your own time, and that way you can have also the PowerPoint. So you want a copy of my PowerPoint with not being recorded, you're more than happy to have a copy of it. Okay, I'm going to put my email on the chat, and if you want a copy, I'll be more than happy to to see you there.
Alrighty, sounds good. Thank you, Mr. Isasi, for presenting the wonderful topic of sets. And thank you to the guests for being great guests. I want to invite everybody to next week's events that will be held during the week. Next week we will be having, here it is, April 30th. We will be doing Math 1314 review session on inverses and determinants of matrices. And for our section of Math 1324, we will be doing basic concepts of probability. So if you guys can stop by next week to learn some more great topics, go ahead and do so.
Do you break the groups in two? Because every time I come in, I'm in the wrong one.
So at 3 p.m. is when we kind of just welcome everybody to the Happy Math Hour event, and then maybe about 2 minutes into the introduction, the host posts a link so that the students can break off into the 1314 room and the 1324. So usually, if you sign in at 3 p.m., you'll sign into the 1314 room, and then the host will then post the specific link so that it brings you to the 1324 room. So once that link is posted, you just have to click it, and then it'll bring you to this room right now. And then you just have to make sure that you close the previous window that you had. That way you're not hearing two separate voices. uh, but yeah, usually the link for the 1324 room is posted maybe a minute or 2 minutes into the introduction done by the host.
Is it the same link every time?
Yes, yes, ma'am.
So I'm just gonna save it then. Thank you.
No, no problem. We also have tutors on standby in case you guys have any questions. Just let us know, and we can put you in a group with a tutor. That way, you can take care of business